Hello and welcome to the first video for Math 207 Fall 2013. This is a video that goes through Quiz 1. So the first problem on Quiz 1 asks you to evaluate this limit, and it's the limit as x approaches 5 of the function x squared minus 6x plus 5 all over x minus 5. We should go through this and do our work using limit laws. We do not need to use a precise definition of a limit for this problem. Okay, so there's a problem up there, and for convenience what I'd like to do is just define the function, give it the name f, and note that the special x value is this number 5 right here. That is what Stewart uses the letter A for, so A is 5. And if we use that label f and a, then the question that's being asked is to compute the limit of f of x as x approaches a. Now note that f of x is a rational function. We talked about rational functions in class, but if you forgot or you just want a reminder, I'd like to go through the process of what you can do to find things. I'd like you to become empowered to use the book as a resource. So go ahead and flip with me to the index. It appears in the book in the very back right after all of the solutions to the odd numbered problems, and on page A144 in the first column you'll see rational function. It's up at the top. It's the fourth entry on that page. And there it directs us to page 30 among several other pages. But let's go to that first one right there. Right, so we'll head over to page 30, and on page 30, there's the definition. Right in the middle of the page, it says that a rational function is a ratio of two polynomials. In fact, a little bit later down on the page, Stewart gives an example of such a function. The example in the book is 2x to the fourth minus x squared plus 1 all over x squared minus 4. Okay, so the point is the function that we have here that we're starting with, f of x, is a rational function. And go ahead and flip with me to the bottom of page 101. There's this direct substitution property in a red box. It says that if f is a polynomial or a rational function and a is in the domain of f, then limit of f of x as x approaches a. That's the thing we were wanting to compute. That's simply the same thing as f of a. So this would be really nice to use because all we have to do then is take the formula for f of x and just plug in a, right? Plug in 5 for each x. Can we use a direct substitution property? Well, we have a rational function, so things look somewhat good, and so, this thing that we're trying to compute here would be the same as computing f of a. But the real problem here is that 5, right? Our current a is 5. 5 is not in the domain of our function f, right? So if you try plugging 5 into this formula, then you're going to get a division by 0. Right? So therefore, for the function that we have, that we've set up, we cannot use the direct substitution property. But what we're going to do is take our function f here, and note that the numerator can be factored, right, as x minus 5 times x minus 1. Now, it would be desirable to want to cancel these things here, but if we do, we actually don't end up with the same function. So we shouldn't cancel this factor x minus 5 that shows up here. But imagine that we did cancel it. Then what we'd have left is this x minus 1, and that suggests defining a new function. I call it g of x, and we'll define g of x. Its formula will be x minus 1. Okay, so our old function, f of x here, and our new function are actually very similar, even if they don't look very similar in terms of their formula. In fact, let's just point out what their difference is. The difference is just a little piece of the domain. See, the number 5 cannot be input into f, but it could be input into g, right? So 5 is in the domain, 5 is not in the domain of f, but 5 is in the domain of g. And other than that, the functions are equal. So, in other words, f of x equals g of x as long as x is not equal to 5. Or said differently, f of x equals g of x if x is not equal to 5. I'd really like to drive this point home. What do I mean by this? Let's actually test this out. I mean, just pause the video for a second. Pause the video after this instruction. But here's what I want you to do. Pick any real number at all. Any real number except 5. have a couple examples here. Pick any number, call that x. Now take your choice of x and just plug it into this formula, and you should get the same y coordinate out, right? As long as you picked x not equal to 5. All right. So that fact that you just verified while the video was paused here, that f of x equals g of x except when x is equal to 5. This is useful because of this thing on page 102. So if you look in the red box there, it says the following. If f of x equals g of x when x is not equal to a, then the limit of f of x as x approaches a is equal to the limit of g of x as x approaches a. So we're really in business. So recall we were asked to compute this limit right here. And since here's our f of x formula, it's equal to g of x when x is not equal to 5, then we can say that the limit of these two different functions, they're pretty related, they are technically different functions, but they're almost the same. These two limits end up being the same. So let's follow along, right? We have this f of x is highlighted both in the formula in the fact and in our instance here, right after since, right here. And we have our g of x's which align, and there's our 5, which corresponds to this a. That same number a, or 5, has to appear here and here, so they appear for us there and there. Right? So this, which we were asked to compute, is going to equal this. And this is great, right? Because the limit as x approaches 5 of what's in parentheses here, well, what's in parentheses is a polynomial. So we can use the direct substitution property. So we're ready. We're ready to put this all together now. We were asked to compute this limit, the limit of x squared minus 6x plus 5 all over x minus 5 as x approaches 5. And we showed that this limit is equal to the limit of some other function, namely the function y is equal to x minus 1 as x approaches 5. And this limit we can compute because the function that we're taking the limit of is a polynomial. So we use the direct substitution property, which means just take the formula and replace each x with that a value, which is 5 here. So we have 5, we have x minus 1 turns into 5 minus 1, and we get 4. All right, thanks for watching.